So whatever external input values you gave for the test case, if you want to be able to use that test case to test the predicate, that test case, those external input values, when you execute your program with those input values, the execution has to get to that predicate, right? Has to reach, has to exercise that predicate. Otherwise, you are not testing that predicate. That makes sense. So from another perspective, like whatever values we are going to give, okay? For example, if I choose 1 and 2, okay? Whatever values I choose to test this predicate, okay? Those values, when you give those values to the program must come to that point, must come to the point where the predicate, so that the predicate is executed. Okay, so that is called retribution. If I want to test the predicate, when I assign values to different variables, I have to make sure the program execution will come to that predicate. So that's one concern. And the second concern is called controllability. So, in general, if you look at the example, right, we have here, remember, like a program, imagine you have an if condition inside your program, right? The conditional expressions, the if condition, the expression may use some internal variables. Okay. Again, the test case that you are going to generate in the end will be values for the external variables. Okay, like the inputs that you take from the command line. So from the tester's perspective, you do not have control. You cannot directly assign values to internal variables. Okay, because the test cases are supposed to be given to the program from the outside, right? You execute the program, for example, in the command line, you're going to put those put the values in the test case on the command line, so that the program can take those inputs and can start to execute. So you cannot when you generate test cases, the test cases are have to be written in terms of values that you give to external inputs, not internal variables. Okay. So if you are going to test the predicate, you say, well, I want you to assign this internal variable. Like here, I want you to say x could be an internal variable. If you want to assign a value, a proper value to x, so that you could satisfy the active class coverage, you have to somehow assign a value to the external variable, so that because you execute your program statement by statement, you get to the point where the predicate is to be executed, the internal variable has the exact value you want. Okay. So again, the idea is that you do not have control, direct control over the internal variables. What you have control is the external variables. So you have to assign proper values to the external variables, so that when you get to the point you want to get, the internal variables have the correct values. We're going to see a specific example so that you can get a better idea to appreciate what these two challenges are. And what I can tell you at this point is that maybe we're going to get back to this important discussion when we talk about how we actually generate test cases. Okay. These two issues are very challenging issues. Okay. It requires understanding about the semantics. Okay. So because of that, they are undecided issues. And these two issues, to a significant extent, are what makes automated test generation really difficult. Okay, remember what we have discussed so far, like graph-based testing. We only discussed how to generate test path, right? We have not discussed how to actually give how to generate test cases yet. Okay, and for which you at this point you have to do it manually. And we're going to discuss more in detail about how to actually generate test cases. And as later you will see, it has a lot to do with how to deal with these two issues. Okay. So we're going to use this as an example. Okay. I know it's very small because I really want to fit it in the same slide. And you have the example in the textbook. You have the textbook. You could probably look at that. And by now, I guess you guys are familiar with this example, okay, called tri-type, right? It's classification of triangles. Okay. But if you look at the code, the implementation is very different from what we have seen before. Okay. But that's really not the point that we want to make here. Again, triangle classification is just a very good example for instructions for class, because everyone understands the domain knowledge, how we're going to do the classification. But anyway, okay, this is the program we want to test. Okay, how are we going to apply predicate test to test the entire program? That's what we're going to discuss. Okay, without having to look at the details of the code, the first step you are going to do is that you're going to identify all the predicates you have in the program. And you can test each predicate one at a time. That's a general idea, okay? So the first step, we're going to identify all the predicates that we have in the program. I don't know if I can, maybe I can zoom, okay? So that's, it's easier for you guys to see. Well, that's the maximum I got. I don't know how much it helps. But anyway, look at this program. What kind of statements are predicates? All the conditional statements, right? If statements, switch statements if we have, I guess here we do not have one, and all loop would be the kind of predicates. So in this case, the predicate, okay, this is the main function, okay, we can focus on this method. So 42 would be the first predicate, okay? And the second one would be 49, right? And 51, 53, okay? So basically you identify all the statements where you have a conditional expression. So this is what we have here. We basically identify all the predicates here. So now, let's say we're going to identify reachability conditions for each predicate. So the idea is this: if you want to test the predicate, you have to make sure the program execution come to the point, right? So which means the test cases that you're going to generate in the end would have to satisfy the reachability condition. Otherwise, if you give the test case to the program is not going to come to the predicate you want to test. So this is additional constraints you have to consider when you generate test cases for predicate testing. Okay. So let's say, let's look at this, how we're going to do this. Like for 42, okay? So we're talking about this 9 42. So for now, you only need to consider this main method. This method, this one basically gets input from the user, which is not really our main concern here. Okay. So if you look at this method, okay, what condition we have to satisfy if we want to execute 42 statement, 942. If we want to execute the if statement, what conditions these three inputs, okay, three parameters have to satisfy if you want to execute 42, 942. So what I see that you can simplify, you can just start execution from here, right? If you execute this method, what condition these three parameters have to satisfy if you want to execute 42? Can you speak louder? Well, they need to be integers, otherwise you're not going to compile. Yeah, you have to be integers. That's kind of enforced by the compiler, right? So that's, if you start like executing this method, you will always execute 42, right? So that's basically is a universal true condition. So it means you don't have to satisfy any additional condition. The predicate will be satisfied. Okay. So look at 49. Okay. The next predicate, 49. Okay. The next expression. What condition we have to satisfy if we want to execute 49?
42 has to evaluate false.
That's right. So 42 has to be false. Right? I hope you can appreciate that it's not, for some predicates you will always execute, but not for all the predicates. Some predicates, if like in this case, if 42 is true, the program is going to return, you're not going to execute what's next, right? So the point is that if I want to do predicate testing, if I only test predicate 49, whatever test cases I create have to make sure the program execution comes to this point, and that means have to make sure 42, the condition in 42 is not true. So that's what we have. Okay, so 49 to the reachability condition of 49 is basically the negation of the condition in 42, and it's basically what we have here. Okay. So I guess from another way to understand is that the size have to be greater than 0. Otherwise, you're not execute. Then we can look at a couple more examples. 51, what would be the reachability condition for 51? If you want to execute 951, what condition you have to satisfy, what constraints you have to satisfy for side 1, side 2, side 3. 51. If you want to make sure 51 is executed. 42 has to be false. Okay, it's the same as the reachability condition for 49, right? Because as long as you execute 49, you would always come down to 51, right? There's no way for you to escape 51, right? So 51, 53 would be the same, right? As long as you execute 51, you will always execute 53. Okay? And 55 will be the same as well, right? There's no way for you to escape 55. What about the next predicate, which would be 59? If you want to execute 59, what reachability condition condition you have to satisfy. So would be 42 has to be false and 55 has to be true, right? So that's what we have here. So now you have an additional one. Try out has to be 0. So I hope you get the idea. Okay. So basically you look at each bracket, you determine what kind of constraints I have to satisfy. You come to this point. I hope this makes sense, because if you want to test the predicate, you have to come to that predicate, right? Otherwise, you're not testing the predicate. Okay. And imagine now we're doing it like manually, right? I guess, as you know, like ideally we want to do it automatically, right? Which we will discuss like probably after security testing or maybe before security testing, which we will discuss. But that's very important, okay? And it's very difficult to do. Okay? But for now, it's sufficient for you to get the idea, okay? What, how do you automate that? That's a different problem. But at least you appreciate. You have to, if you want to test the predicate, you have to be able to copy that predicate. Okay, that's the basic requirement before you do predicate testing. So now that is reachability issue. Okay, it's something that you have to consider when you test when you do predicate testing for the program. And there's another important issue, which is called how you're going to assign proper values to internal values. Okay. So, for example, here, if you look at 59, this predicate, okay, 59, this predicate, okay, the reachability condition has to make sure try out equals 0, right? If you want to get to that predicate. But try out, when you generate test cases, you cannot directly assign a value to try out, right? What you can do is that you say, well, I'm going to give some value to each of the 3 sides. And you have to make sure that if you want to test predicate 59, you have to make sure the 3 sides have proper values, such that when you get to 955, that condition when you check if try out is 0, at that point try out has to be 0. Okay? So I guess you do not have direct control over the value of try out. What you have is that you have indirect control. Okay, you can assign different values to side 1, side 2, side 3, but you have to make sure after you have executed all the statements before 55, okay, the internal variable try out will have 0. Okay. So as you can see, from a certain perspective, it means you have to be able to understand the semantics of all the statements that come before 55. Only if you understand the semantics, then you can say, well, I know what kind of values I assign to side 1, side 2, side 3 will help me to make sure try out is 0 when you execute statement 55. Okay. So to do that, you have to understand the relationship between try out and the 3 sides. Okay? And this is the relationship we can divide based on the code. Okay? Again, we are doing this manually, and if you want to do it automatically, it can be quite challenging. And let me explain what this means. Okay? See, basically what this means is that if I want to make sure try out equals 0, okay, at 955, I have to make sure all the 3 sides, okay, are not equal to each other. All the 3 sides are different from each other. Okay. So how we derive this is that basically you have to look at the statement, okay? Look at how try out, how this internal variable try out is assigned. Okay. So if you look at the statement like 48, basically try out, if we, because we're talking about 55, right? All the statements that come before 55, okay? So the statements where try out is assigned a value would be 48, 49, 50, 51, 52, 53, 54, right? If you want to make sure try out equals 0, that means you cannot execute 50, 950, right? Or 52, or 54. As long as you execute any of those statements, the value of try out would not be 0, okay? So by reading the statement, you know if you want to make sure try out equals 0, then the three sides have to be different, right? Because as long as you have two sides are the same, then the value of try out would not be 0. That makes sense? Because you have to execute either 50, 52, 54, then the value would not be 0. So this is how we derive, like for try out to be 0, this condition has to be satisfied. When you generate test cases for the three sides, you have to make sure S1, S2, S3 basically represent side 1, side 2, side 3 are different from each other. Does it make sense? So from a fundamental perspective, you have to figure out the relationship between external inputs and the internal variable, the value of it. In general, that means you have to be able to understand the semantics of all the statements that you execute. Okay? And that is difficult. That is what really makes testing very challenging for stakeholders. Okay? And to just look at another example, let's say try out equals 1. If you want to see, if you want to make sure try out equals 1, what values, what kind of constraints you have to satisfy for side 1, side 2, side 3. Okay. So again, we have to, at this point, we have to do manual analysis. Okay. There are alternative techniques that we can use, but that is a more advanced topic. So manually, if you look at this, if you want to make sure try out equals 1, which condition you have to satisfy? You have to execute 50, right? Statement 50, but not the other two statements, 52, 54. You cannot execute 52, 54, right? As long as you execute 52, 54, you are not going to have try out equals 1, right? So after you have this understanding, then you can derive the constraint, okay, which would be S1 has to be the same as S2. You want to execute 50, right? 50, but not 52, 54. The other two conditions, right? So again, I hope you get the idea. Okay, it really requires understanding of semantics, and that's really challenging. Imagine if you have a more complex program. Yeah, that's really what makes testing challenging. But from another perspective, okay, if you look at testing, as I mentioned, or software engineering in general, we deal with semantics. Okay, that is a challenging problem by nature. Okay, this probably you just cannot get around it. Okay? That's what makes software engineering challenging and also interesting, right? So I do want to point out, like if you look at this one, this condition, okay? This condition is a contradiction, right? You can never hyperman. Okay? And 5. Okay. is also a contradiction. You cannot have 4 and 5. So if you look at the program, you can say there's no way for try out, okay, to be 4. Okay. So if you want to make try out to be 4, you have to execute, basically you have to execute what? Statement 50 and 54, right? Without executing statement 52, right? And that's not possible, right? Yeah. So you have to make sure S1 equals S2, S2 equals S3, but S1 is not equal to S3, so that's not possible. So actually, if you look at the program, there's no way for tryout to be 4 and 5. So now, after we figure out this relationship, then we can rewrite reachability condition so that they are expressed in terms of external variables. Okay. The tryout, whatever value we want to give to tryout, has to be replaced with the constraint on the 3 external input variables, so that when we try to generate test cases, we can make sure those additional constraints are satisfied. Okay. So basically, it's a rewrite. Okay, so if you look at the 59 condition, the reachability condition for 59, if you look at here, you have tryout equals 0, right? That's an internal variable. We have to rewrite that condition in terms of the 3 external variables. Okay. So we do that for every reachability condition that involves tryout. Okay. And so that we have all the reachability conditions written in terms of external variables, S1, S2, S3. Now at this point, okay, we are ready to actually generate test cases for predictive testing. Okay. So what we do? So we're going to look at predictive coverage first. We're going to do it one by one. Okay. We're going to do the first predicate would be 42, right? We want to generate 2 test cases. One test case will test the predicate to be true. The other test case will test what happens if the predicate is false. So when we generate test cases for this one, okay, you can apply whatever we discussed before, right? So this is basically a predicate, right? Okay. But in addition, you have to make sure whatever test cases you're going to select, whatever test cases you're going to generate here, ABC represents S1, S2, S. EO represents, can you guess? Expected outcome. Okay. So whatever test case, in this case, like ABC is 0, 0, 0, has to satisfy the reachability condition. You have to make sure the reachability condition is satisfied. So, like if you look at 42, the reachability condition is universally true, right? So basically, you don't have any additional constraints to satisfy. However, if you look at other predicates, look at 42, 49. Okay, if you want to generate, just want to generate test cases to satisfy predicate coverage, you only need to have test cases where S1 equals S2 and S1 is not equal to S2, right? If we do whatever we discussed before, you could give -1, 1. You could give if you do not consider the reachability condition, you could give -1, -1, 1 would be one test case, and -1, one would be the other test case. That would satisfy predicate count for this predicate. Side one equals side two, side one is not equal to side two. But these two test cases would not work. As you guys cannot see. So, like for 49, if you give -1, -1, 1, -1, -1, 1, this would be a embodied triangle would be 4, right? This would be one test case, right? 4 is the embodied triangle if you look at the 4. Remember, you have 3 types of triangle. If you have negative number, it's an embodied triangle. Okay, so that's the expected output. So this test case does, if you apply this one to the predicate will evaluate to true, right? But it's not going to work for us, right? So if you look at the program, okay, if you look at the program 49, right? If you want to test 49, if you give -1, -1, 1, what happens? We get to 42. It's going to return, right? You're not going to come to 49. Okay. So the point I'm trying to make is that if you just look at the predicate, you could get -1, -1, 1, but that does not satisfy the reachability condition. So in order to satisfy the reachability condition, all the 3 sides have to be greater than 0. That's what we have here. Okay? So that's why when you select test cases to test this predicate, you have to make sure all the sides are greater than 0. Okay? So we do not have negative values. I guess the idea is that when you generate test cases, you have to consider additional constraints imposed by the reachability. And you can do that for every test case, okay? And remember, okay, not only reachability for this one, the predicate itself has tryout equals 1, right? And if you want to make sure this condition is true, you have to go to look at the tryout equals 1. If you want to make tryout equals 1, then this condition has to be satisfied. It means S1 has to be the same as S2, but S1, but they cannot be the same as S3. So if you look at the test case here, you have to make sure that, because tryout, if you want to make this condition true, you have to make sure S1 is the same as S2. That's what we have here. S1 is the same as S2, but they cannot be the same as S3. Okay? So there are additional constraints that you have to consider when you apply predicate testing to programs. And this is how you do class coverage. I guess pretty much similar. The main idea is that you do whatever we discussed before, just test individual predicate, but when you generate test cases, you have to consider reachability condition. You have to rewrite internal variables in terms of external variables. But those are what I will control. I just want to mention when you look at the table, like here you have all the predicates, right? That we have identified. Like for the class coverage, it only makes a difference if the predicate has more than one class, right? So that's why we cannot have this predicates in this table, because they are the same. If we only have one class, predicate coverage is the same as class coverage, right? It's a special case. Okay. And you can do CACC, you can check. Okay. Just do whatever we do, but when you select test cases, you have to check reachability condition. You have to rewrite internal variables. That's what summarize, we have this hierarchy. Okay. On the top is basically the exhaustive coverage to test all possible combinations. Okay. And on the left hand side is RACC, CACC, GACC, the active class coverage. And as we mentioned, RACC is the strongest, and the CACC and GACC. On the right hand side, we have inactive class coverage is kind of similarly defined as active class coverage, but I don't think they are introduced from a theoretical point of theoretical interest. They are not really used. Okay, in practice, I just want to put it here, but you don't have to really understand that. On the bottom, you have class coverage and the predicate coverage. We discussed neither is stronger than the other. Okay. So you do not have a subsumption relationship. But CACC is stronger than predicate coverage, right? And the GACC is stronger than class coverage. But GACC is not stronger than predicate coverage. So the main idea of predicate testing I want you guys to remember is that basically we're trying to deal with the masking effect. Right? We want to make sure if we want to, if we write the class, we test the class, what is the impact of that class? That's the whole point of predicate testing. And when you apply predicate testing, you have to consider reachability and controllability when you apply predicate testing. And we made it. We finished the class, the predicate testing topic. Next,
We've talked about it for a month now.
yeah, that's right. Yeah, because we had the midterm and it's really great. Yeah.